Lesson 3 of Chapter 3 of Probability and Statistics. Our topic today is normal distribution. Our essential outcome is that you will be able to create and apply the basic properties of the normal distributions. So, the normal distribution is a type of density curve. It's a density curve that is symmetric around the mean and the median, and the area under the curve, it equals 1, and the standard deviation of this one is 1. And so what you should be able to see on every normal distribution is 3 standard deviations on each side. So you see would be the mean or the median at 0, and the distance between 0 and 1 right here is our standard deviation. And from 1 to 2 is a standard deviation. From 2 to 3 is a standard deviation, and the same in the other way. And we notate standard deviation with this S and then sub x. So that is a normal distribution. So here we have 3 different curves. And the standard deviation of a normal curve, what it controls is the spread of the curve. And so in this first one, it's kind of a long, it's kind of a longer graph, kind of a fatter graph. And so when that happens, we have a larger standard deviation. You see that space under the curve, that distance along the x-axis is larger. Okay, so when the standard deviation goes up, we get a larger or a wider. It's a wider but shorter curve. And when that standard deviation becomes smaller, we get a taller and a narrower normal distribution. And so right here you can see like your typical normal distribution. So that standard deviation, it affects the spread of our curve. And so if we look at this next one, we're going to rate these in order from the smallest distribution to the largest standard deviation. So we look at these, remember, the taller and narrower the curve is, the smaller the standard deviation will be. So the tallest and narrowest one is F, so that's going to be our first one. And then if we look, it looks like the next one is C. Then it looks like we get A, B, D, and then E. So about the average, the typical normal distribution curve would be A and B. Those would be our most average one, whereas these other ones are going to be, you're not going to see them quite as often, but they are normal distributions. They just have different, either a very small or a very large standard deviation. And so here we can kind of think about that when you're thinking about a sport or something, this middle portion, it's about 1 standard deviation away. This is going to be the people who are pretty average at that sport. And if it's more than 1 standard deviation below, they're going to be the people who are low performing at that sport, or they're not very good at that sport. The people who are 1 or more standard deviations, they're going to be the high performers, people who are very good at the sport. And so if you think about it in golf, right here are our professional golfers. That's going to be like 2 or 3 standard deviations away. It's a very small percentage. And then down here, 2 or 3 standard deviations in the other way are the people who just can't even swing the golf club. And so that's going to be another very small percentage. And so that's kind of how the normal distribution works. So here we have a normal distribution, and so we're going to estimate or approximate the mean and standard deviation of this curve. And so the mean is always in the middle, so it's right about here. I'd say it's about 65. Remember, mean is x bar. Okay, and if we look at this, we need to be able to fit 3 standard deviations underneath here. So what if we did 1, 2, and 3? That seems to fit pretty well. Do the same this way, 1, 2, and 3. So I would say our standard deviation then could be about 4.5 or 5. 4.5 or 5. And that was our, remember we called that S sub x, and our mean x bar was about 65. That's the one in the middle. So that's what you're going to be expected to do on the homework for a lot of this, is be able to fill in where those would be. And so here we have another one. We have body weight in pounds and the frequency in percentages. And so we need to approximate the mean and standard deviation of this normal density curve. So we look for the middle. The mean looks to be about here, about 200. So x bar equals 200. And then we need to fit 3 on each side. So 1, 2, 3. And that third one should be pretty close to the tails. 1, 2, 3. And so there are about 4 sections between 200 and 100. So I would guess the standard deviation then is going to be about 25 pounds. It's as simple as that. Alright, so what you're going to do now is you're going to draw a normal density curve that has a mean of 180 and a standard deviation of 15. And then you're going to answer this question about what is the value 2 standard deviations above the mean. So pause the video now and make that. Alright, there you can see my normal density curve. Notice it's not a perfect drawing by any means. My mean is at 180. My standard deviations go by 15, so I get 195, 210, 225. I couldn't fit the other ones this way, but I would have 165, 150, and 135. I'll at least write that one in. So what is the value? 2 standard deviations above the mean. It's going to be above the mean, which is going to go this way. 2 would be right here at 210. Alright, this is the end of lesson 3 of chapter 3, normal distributions. Write your summary and your questions. The essential outcome for today was that you'll be able to create and understand the basic properties of a normal distribution.